Hi class, let's take a look at problem 40. Now in problem 40, we're given a graph and they want us to use the vertical line test to determine if the actual graph is defined as a function. Now here's the basic idea. You would draw a vertical line somewhere on the actual plane. And give me just a second. Here, I'm just gonna leave it in this position. And you're moving it around and checking to see if an x value it's going to give you multiple y values. Now in this case, wherever you place the actual x, your actual vertical line, which in this case it represents an x equals to a numbered line, wherever you place it, you're only going to have a single intersection. So when you're writing your statement, you want to say something along the lines of yes, in this case, the graph passes the vertical line test. Every x value has a unique output, meaning you're not going to encounter an x that gives you multiple y's. It doesn't matter where you move it because it's a curve. You're only going to have a single intersection. Now, let's take a look at another graph. And here I already placed the vertical line. And here's the basic idea. Wherever you move this one, you're going to have multiple y values. So in this case, I'm using 3. And notice that at the values of 3, you have 2 intersections. So in this case, no, this graph is not defined as a function. The graph doesn't pass the vertical line test. And then here, the x value of 3 actually has 2 outputs. We're looking at this value, which is about 1.7. I'm estimating it. And then technically this value, which is 3, negative 1.7. So when you have an x value giving you multiple y values, they're not defined as functions. Or in this case, this graph is not defined as function. The previous one, since you only have a single intersection, it is defined as a function.